Okay guys, let's have a look at the intro then for geometric progressions. That will G in there. Geometric progressions, basically what are they? Well, they're sequences or a series is the term we use more commonly, whose successive terms are a constant factor times the preceding term. Any series like this, which has a constant factor times the preceding term, is called a geometric progression and abbreviated as a GP. So let's have a look at some examples then. We got 12, 6, 3, 1.5. You can see that each successive term is half times the preceding term, can't you? So 6 times a half gives you the next term, 3 times a half gives you 1.5, and so on and so forth. This is clearly an infinite geometric progression here because of the dot dot dots. It means the sequence continues. And so that's a geometric series then, geometric progression. Here we're timesing each subsequent term, timesing the term here by -2 to get to the subsequent term. Yeah. So 2 times -2 is -4. Times another -2 is +8. Times -2 is -16, and then +32. So each term is -2 times the one before, or the preceding term. We can use some general notation then, denoting the first term by A, and the multiplying factor by R, so that which is called the common ratio. We may write this Sn, the sum of the first n terms. Here's the first term. R is called the common ratio. So let me just put that in. Common ratio, that's what it's termed. More often than not, A is termed the first term. Yeah, so you got A as the first term, then you times by R to get AR, the second term. Then AR squared, that would be the third term. So the nth term then, notice that we started from effectively R to the 0 here, because R to 0 is 1, and then it was R to the 1 was the second term. So here the nth term will be AR to the 1 power less than n. So it's AR to the n minus 1. If we want to write it in sigma notation, here it is here. AR to the k's, we started from 0, so we must end at n minus 1, and that will give us n terms on term. So be careful there, it's a common mistake to write down the last term or the nth term incorrectly. So if we take A as 2, R as 6, R as 3, and n as 6, then we can write down the sum of the first 6 terms of this GP. It would be A, 2, AR would be 2 times 3, AR squared, 2 times 3 squared, AR cubed, all the way up to the 6th term, which is AR to the 5, 2 times 3 to the power 5. So this is 2, 6, 9 2s are 18, 27 2s are 54. Then you carry on, and basically you times in by 3. So times that by 3, you get to 162. Times that by 3, you get 486. And there's 1, 2, 3, 4, 5, 6 terms in the sequence. That's the sum of the first 6 terms. Okay, then that's a little just overview then of geometric progressions. Hope you're going okay in this section. The derivation of the formulae for the sum of the first n terms of a geometric progression I've left to do in the on long click method in the intro. So if you get a chance and want to have a look at that, then just hold your finger down on the on long click on the app. Okay guys, all the best then, and I'll catch you again in another section. Cheers!